Hello everyone, my name is Rakim Chandra and I am the team lead of Team Vortex. Today I am presenting MedGraph-RAG, our submission for the GraphRAG Inference Hackathon by TigerGraph. What you are looking at right now is our GitHub repository, open source, fully documented and ready to run. In the next 6 minutes, I am going to show you exactly how our team cut LLM token costs by 67.8% while simultaneously improving the answer accuracy to 93%, thus hitting both bonus thresholds at the same time. Let's get into it. Into the problem. Let me start with the problem we set out to solve. Imagine you are a medical researcher and you ask this question: what approved drugs target proteins in the BRCA1 DNA damage response pathway? To answer this correctly, you need to reason across a chain of relationships. BRCA1 interacts with RAD51. RAD51 participates in homologous recombination. Homologous recombination is disrupted by BRCA1 deficiency, and BRCA1 deficiency exploited by OLA-PARAB and FDA-approved drug. What that is a three relationship hops. Standard vector RAG cannot do this. It searches for text chunks that mention BRC1 and drugs and then dumps 1400 tokens of loosely related paragraphs into the LLM prompt, hoping the answer is somewhere inside. Most of it is noise. You are paying for noise. We built MedGraph-RAG to prove there is a fundamentally better approach. Our dataset. Our dataset is the PubMed Open Access Cancer Research Corpus, containing 7,170 chunks, totaling 2.1 million tokens of biomedical literature covering genes, proteins, drugs, diseases, and molecular pathways. You can see our questions.json file here. 100 expert reference answers generated by state-of-the-art language model and verified for biomedical accuracy. This is the gold standard we benchmark all three pipelines against. And here is a benchmark, and here is a benchmark dot results JSON, the full results. Here is a benchmark results.json, the file containing the full results. We look at these numbers in detail in a moment. Let me now show you the three pipelines live. Pipeline 1 is a worst case baseline, a raw LLM with no retrieval whatsoever. The question goes straight to the model with no context. Let me run it. You can see the model produced an answer, but look at the token count. For a single question, the LLM is generating hundreds of tokens of response because it has no precise context to anchor to. It hedges, it elaborates, and it repeats itself. Across a full 100 question benchmark, the average is 3,847 tokens per query at a cost of $0.00231 per query, and the accuracy only 61%. LLM judge pass rate, expensive and inaccurate. Pipeline 2 is what most production teams use today. ChromaDB vector embeddings with semantic similarity search. We retrieve the top 5 most similar chunks and injects them into the prompt as context. This is the industry standard approach. Better answer, but look at the token count. Over 1500 tokens for a single question. The 5 retrieved chunks are topically related, but they contain a huge amount of surrounding noise, citation headers, author names, and unrelated sentences. Because vector search finds what looks similar, not what is precisely relevant. Our benchmark shows 1442 average tokens per query, 74% pass rate at $0.00128 per query. Better accuracy in an LLM only, but we are paying a massive token tax. Now, pipeline 3, GraphRAG with TigerGraph. It is where everything changes. Instead of searching for similar text, we extract the key biomedical entities from the question, then traverse our TigerGraph knowledge graph using 3-hop GSQL queries and assemble only the precise relational facts the LLM needs to answer. No noise, no padding, just load bearing facts. Look at that token count. A fraction of what basic RAG used. Across a full benchmark, GraphRAG averages 687 tokens per query, a 67.8% reduction versus basic RAG. But here is the critical insight. Accuracy went up, not down. Our benchmark shows 93% LLM judge pass rate and BERT scored F1 of 0.61. Both bonus thresholds hit simultaneously. Token reduction and accuracy improvement are not intentional when you use a knowledge graph. Precise retrieval means fewer tokens and as well as better answers because every single token in the context is load bearing. Here are the complete benchmark results across all biomedical questions. LLM only 3,847 tokens, 61% accuracy. Basic RAG 1,442 tokens, 74% accuracy. Graph RAG 687 tokens, 93% accuracy. Birth score 0.61. Both bonus thresholds exceeded. Now let's talk about what this means at scale. At 100,000 queries per day, a modest production workload for any technical information system. Basic RAG costs $384 per month, GraphRAG costs $123 per month. That's $261 saved every single month. Just imagine $261 saved every single month while delivering more accurate relationship aware answers. The knowledge graph pays for itself immediately and then keeps saving money every single day. The full technical deep dive is published on Medium. Link is in the description of our submission files, where we walk through every architectural decision, the parameter tuning process, and the GSQL multi-hop query design. Everything is open source at github.com. Raktim Chandra, MedGraph-RAG. This is Team Vortex. Raktim Chandra, Nipun Devangan and Juhi Hai. Built for the GraphRAG Inference Hackathon by TigerGraph. Vector RAG was the right answer for 2022. Knowledge graphs are the right answer for 2026. Thank you.